all the definitions and formulas of 8th class maths of chapter direct and inverse proportions. First definition, proportion. Variation in one quantity leads to variation in the other quantity is known as proportion, means how it varies. For example, if Gopi uses 4 cups of water to cook 2 cups of rice every day, when any guests arrive, then rice increases. That leads to number of cups of rice increases. That leads to increase in number of cups of water too. Means variation of one quantity, it leads to change in other quantity. A proportion, it is of 3 types. Usually direct inverse 2, but another one, third one also there. So there are 3 types of proportions. Direct proportion, as the ratio is same, we call this variation as direct proportion. Ratio here, it seems, it means if change in one quantity leads to the change in other quantity, that ratio which we take, it will be a constant value. If x and y are any 2 quantities such that both of them increase or decrease together and x by y remains constant, say k, let that constant be k, then we say that x and y are in direct proportion. This can be written as x is directly proportional to y and read as x is directly proportional to y. It is written as when x is directly proportional, then their ratio will be a constant value. That implies x is equal to some constant value should be multiplied to the y. As if x changes with the same constant values product, the second quantity will change where k is constant. So while applying this direct proportion, there are 2 formulas we'll use. If y1 and y2 are the values of y corresponding to the values of x1 and x2 of x respectively, then x1 by y1 is equal to x2 by y2. Or else we can say when x2 comes here, y1 goes there, then it becomes x1 by x2 is equal to y1 by y2. Example, volume of water in a tank is directly proportional to time required to fill the tank, because when volume of water in the tank means water to be filled increased, then time taken also will be increased. If length of the cloth, if we buy more cloth, more length of the cloth, then cost will be increased. Next, inverse proportion. 2 quantities change in such a manner that if one quantity increases, the other quantity decreases in the same proportion and vice versa. This is called inverse proportion. Symbolically, it is represented as x is proportional to 1 by y, or we say x is inversely proportional to y. Yeah. And then when we write like this, to remove this proportional symbol, we have to write a constant here. X is equal to k by y. When we multiply y this side, when we take it to the left side, LHS, it becomes xy is equal to k, where k is constant of the proportionality. X is inversely proportional to y. It is read as inversely proportional to y. If y1 and y2 are the values of y corresponding to x1 and x2 of x respectively, then x1 into y1 will be is equal to product of the x1 and y1 is equal to x2 into y2, that is equal to k. If you take x3 into y3, x4 into y4, any product, that will be equal to a constant value. Or else we can write like this, x1 by x2, y1 comes down, y2 by y1, x1 by x2 is equal to y2 by y1. In this case, x1 by x2 is equal to y1 by y2, but here x1 by x2 is equal to y2 by y1. Here it is example for inverse proportion. If number of people increases to build a wall, then time taken will be decreased. In a book, if number of pages read increases, the number of pages unread will be decreased. Next, third one, compound proportion. If change in one quantity depends upon the change in 2 or more quantities in some proportion, then it is equated as ratio of the first quantity to the compound ratio of the other 2 quantities. When one quantity depends on the 2 or more, then we have to consider their compound ratio. It is of three types again. One quantity may be in direct proportion with the other two quantities, or one quantity may be in inverse proportion with the other two quantities, or else one quantity may be in direct proportion with the one of the two and in inverse proportion with the remaining quantity. Then in three cases, how we'll apply this formula. If y1, y2, y3 are the values of y corresponding to the x1, x2, x3 of values of x respectively, then ratio x1 is to y1 is equal to compound ratio of x2 and x2 is to y2 and x3 is to y3, because both are directly proportional. If one quantity is direct proportion with the other two, then x1 is to y1 is equal to their compound ratio. This should be product of the means should be ratio of the antecedents and product of antecedents and product of consequence. Here x2 into x3 is to y2 into y3, that will be compound ratio, and it is also written as x1 is to y1 is equal to x2 by y2 into x3 by y3. These are direct ratios. x1 by y1 is equal to x2 by y2, it is direct ratio. x1 by y1 is equal to x3 by y3, it is also direct ratio. So product of the direct ratios will take. Second one, inverse ratios of x2 is to y2. Then it is inverse ratio will become y2 is to x2. Here also y3 is to x3. Then its product, compound ratio, y2 into y3 is to x2 into x3. So it is written as x1 is to y1 is equal to y2 y3 is to x2 x3, and also it is written as y2 by x2 into y3 by x3, because both are inverse here. x1 by y1 is equal to, here it is to x1 is to y1 is equal to y2 by x2 into y3 by x3. Next, if one quantity is direct proportion and other is inverse proportion, in this case inverse will change as y3 is to x3. So now x1 is to y1 is compound ratio of x2 is to y2 and y3 is to x3. Therefore x1 is to y1 is equal to x2 into y3. See here, x2 into y3 is to y2 into x3. It is also written as x1 is to y1 is equal to x2 by y2 into y3 by x3. Here we have taken compound ratio of one direct ratio and the other inverse ratio. Thank you. If you like my video, please share, comment and subscribe. Thank you.